topic is going to be TCP. It is one of the protocols in your transport layer. Transmission Control Protocol. So what is connectionless and connection oriented protocols? What is connectionless? Automatically when it comes to connectionless and connection oriented, what comes to your mind? Wireless and wire. But the connectionless is if I want to communicate between a system A and B, there is no prior connection to that. That is called connectionless. I need to send the data from A to B, and before sending the data, both the machines are connected. They are called as connection oriented. It may be wired or wireless, whatever. Here, this is the meaning for connection oriented and connectionless. So UDP is the connection. UDP is connectionless protocol, which we have seen in your previous class. TCP is connection oriented. Then what is reliable? If you have flow and error control in your protocol, then it is reliable. If you do not add flow and error control, it is unreliable. So in transport layer, it is according to our priority. If we need, we can use flow and error control. If not, no need to use error and flow. So let's see what are the TCP services. First is going to be process to process communication. So as you know, transport layer is process to process communication and it supports that. Next is street delivery service. In UDP, how do you send the data? Most of you are not in the class. So in UDP, along with your header, you are going to transform your data. You have seen the format, right? So here also it is going to be in the same format, but it will be in the form of stream of bytes. Your data will be splitted and it will be sent in a stream. Okay? So there you will be sending all of your data at once. Here your data will be splitted into bytes and then it will follow a stream oriented delivery. See, this is your data is going to be sent. So the cube is an imaginary part. In the same way, your data will be sent from the sending process to the receiving process. It will be in the form of bytes, stream of bytes. Your actual data will be split into bytes. Clear? Have you heard of bit of buffers? In your second unit? What is buffers? Here I keep on sending the data. Receiver cannot get all the data at once. It needs some space to store the inputs and then one by one it will be processing. That temporary storage is called as buffer. See here. This is your sending process and this is your receiving process, and here you are having your buffer. So the data to be sent will reach your buffer, and then one by one it will be allowed in the bytes, stream of bytes in your imaginary cube, and then you will be getting in the receiving buffer. So receiver will store one by one and it will take time, process the data and then use it. Clear? What is the use of buffer? Are you clear with what is the use of buffers? See here, three data are in the sent and 4 or 5 are unsent. So even though they are sent via the buffer mix, it did not get any acknowledgement from the receiver side that your data has been sent. After getting the acknowledgement, it will be discarded from your sender buffer. And then here, one by one, buffer will be going to the receiver process and it will be processing it and then call the next data. Processing it and then call the next data. This is the use of buffers. Next, segments. So while teaching the OSI layer, I have told about segments. Anyone remember? TCP layer, we know that it is going to split the data and send in a bytes. In data link layer, how will our data be? Frames. In our network layer, package. So here, using TCP protocol, it will be in the form of segments. While teaching the OSI model, I have already mentioned this. So your bytes will be combined and then sent in the form of segments. See here. So this is one segment. The bytes will be combined in there. Then number of segments will be sent from your sending process to the receiving process. After your transport layer, which layer is there? After your transport layer, which layer is there? Network layer. So network layer is going to accept the data in the form of packets. So it does not accept bytes. Your segments will be converted into your packets when it is moving to your network layer. Next is full duplex communication. What is full duplex communication and half duplex communication? In both the directions. So here, your communication is going to be in both the directions. It is not unidirectional. While A is sending data to B can also send data to A. So that is full duplex communication. So next is we have seen already connection oriented service. If A connection oriented service. connection between both the host, both the systems which need to send the data. Next, it will exchange the data, and the last step is it is going to terminate the connections. So we will see how it exchanges the data and how it is going to terminate and start the connection later. Next, it is reliable services. So flow and error control will be added. Features of TCP. First is numbering. While sending the data in the transport layer, you get in the same order which you have sent the data. Am I right? While asking what is transport layer, someone increase. So, in the same order, you will be getting the data in transport layer. How will you get it? In the same order. So, we are using numbering in that. First, it will be a segment number. First is sequence number and then acknowledgement number. So it creates a random number between 0 to 232 minus 1. So for example, I am going to say 4 segments in an order. So the number may be any number. For example, the random number generated may be 10. Then next will be 11, 12, 13, 14. So from where it is starting, it will be the number from that. It may be any number. Next is acknowledgement field. So your acknowledgement field in the segment defines the number of next data to be transmitted, next byte to be transmitted. So that will be your acknowledgement number. For example, I have sent the data of 10012 to 1002. Now my acknowledgement is 7001. The next my sending byte will be of 7001. Just have a great understanding of it. While teaching the connection between them, you will be understood clearly. So this is an example of how we are going to number. Suppose the TCP connection is transferring a file of 5000 bytes. The first byte is number 10,001. What is the sequence of each segment? If data are sent in 5 segments, each carrying of 1000 bytes. For example, there is going to be a TCP connection and 5000 bytes are going to be transmitted. They are clearly given that you are going to have 5 segments. In 5 segments, each segment will have 1000 bytes. Clear? So how is it going to be numbered? So totally are having 5000 bytes. Okay. So now how will your data be transferred is? So this is how your data is going to be transmitted. So this is your segment 1, segment 2, segment 3, 10,000 bytes. So for those each byte, your address will start from 10,001. Then for 1000 it will reach 11,000. Then in next segment it will be from 11,001 to 12,000. So in the next segment 12,001 to 13,000, 13,001 to 14,000 and 14,001 to 15,000. This is how your numbering happens. So next is flow control. We have seen flow control in our topics. What is flow control? So it will know its flow, how many data a sender is sending, how many data is received by the receiver, how many are pending, how many are on the way to the receiver. Everything comes under your flow control. Then error control. What is error control? So to identify the error and correct it. Next is going to be congestion control. Have you heard of the term congestion? Have you heard of the term congestion? Have you heard of the term congestion? I feel so congested here. What does that mean? So, if somewhere the capacity of the glass is 60, but here around 500 are sitting, then it is called as congestion. A network capacity is, for example, 1000 bytes, but if it is going more than 10,000, then there comes a congestion. So number of load is more than the capacity is called as congestion, and for controlling that we use congestion control. We will see that in detail. So this is how your segment is going to look like. So this is your segments. You will be having your header and then your data. So here inside your header you will be having your source, port address and destination port address. What is the port address? Address of your process. So in your system, for example, here in the laptop I have opened, my laptop has an IP address. If it is connected to my mobile phone, I am opening Google and I have searched for computer networks and I open one page. So that page will have a specific port number. So that page will have a specific port number, that is called as port number. Next is sequence number. What is sequence number? Number of the bytes that is sent in the segments. Acknowledgement number. Next is header length. reserved is, the space is reserved for some data. Next, then URG, ACK, PSH, RST, SYN, FIN. So these are all that is mentioned in your red color are called as control fields. Next is window size. Sliding window. What is sliding window? So next is your checksum that is used for error detection and correction, and then urgent pointer. So your urgent pointer refers to any urgent data that is needed to be sent. So that refers to urgent pointer, and then options and padding. Extra information you need to add, extra actions you need to give. Then that will be inside options and padding. So this is the control field. First is URJ, that is URJ is a flag that is used to represent your urgent pointer. So if there is no data sent in the urgent pointer, then this flag is not valid. This will not contain any information. If you have something in your urgent pointer field, then you will have data in this. So there is for red color, right? So in that red color this will be there. Next is ACK, that is for acknowledgement field. Then it is push to send the data, push the data. Next, synchronization. RST is rest the communication connection, and then SYN is for synchronization, and last is for fill, that is you are going to terminate your connection, you are going to close fin flag. Next we will see the TCP connections. So your TCP connection is going to be of 3 phase. First is making a request for connection, that is this. Then it is data transfer and then terminating the connection. Here they have mentioned 3-way handshaking. So that is, here first it will ask for a connection and then it will give the acknowledgement and then this will say okay for that. That is called as 3-way handshaking. First, this is going to send the client is going to ask the server for communication and here your sequence number is 8000 but you don't have any acknowledgement field. Once the data is received here, it is giving you acknowledgement of 8001. Then next your 8001 packet will be given. So this is what this acknowledgement refers. So A is your acknowledgement flag and S is your synchronization flag. If you have F here instead of S, if S is not there and you have F here, then it is for terminating the connections. So this is connection establishment. So if you have opened the connection, then next is going to be data transfer. See here. First, client is sending the data. You are having P, that is push flag. Push flag is used to push the data. That is to send the data. First, your sequence is going to be 8001 and then the acknowledgement for that is 15001. So here the acknowledgement is 15001. Next, again it is sending a data, that is 9001 and the same acknowledgement is there. So what does that mean? It is sending the same acknowledgement. What does that mean? Because client wants the data of 15001. First, it is sending a sequence number of 8001. What is acknowledgement number? In general, what is acknowledgement number? Here, what does that mean? If acknowledgement has been acquired, then your data is sent. First point. Next is, what does that acknowledgement number refers to? Is the data that is to be sent. Next data that is to be sent. Yeah. Next data that is to be sent will come under acknowledgement number. So see here, acknowledgement is 15001. Then what your data is sending? Sender, server, what is it sending? Your client is sending 2 data. So first is sequence number 8001 and your acknowledgement for that is 15001. So here acknowledgement refers to the data that will be received by the client from the sender. So next is also 9001 and your acknowledgement is 15001. See the data that is sending by the sender. What is the sequence number? And what is the acknowledgement? See here, what is the sequence? And then acknowledgement is something thousand. So when server is sending the data, it will send sequence number of 17,001. Termination. So in termination, instead of this, you will be having a F flag, that is fin command. So So first your client is asking for terminating the connection, then your server is asking for terminating the connection, and then your connection is closed. If N is mentioned in the control flag, then your connection is terminated. Next is half duplex. Half duplex means if one end cuts the connection also, other end can go. Half duplex is going to be one-way communication. So here, see, using pim command, client have closed the connection. This client is not going to send any data more than that. So after that only, your server is going to send the data. And finally, you have seen an acknowledgement. That is only your acknowledgement. It says that I have received your data. If you need to send again. That is half duplex. So one side will connect communication and the other side will be going with sending the data. It is called as half duplex.